The cockpit of an ATR-42 on approach. No problem landing at the airport in Limoges. Yet this flight is special because the pilot has initiated the approach and landing using signals from space. In the Limousin sky, the French civil aviation control plane passed back and forth over the runway to test the new procedures, based on the EGNOS system, guided by signals transmitted by satellites.
Golf Bravo Sierra, you're leaving my area, squawk 7000 and you may leave my frequency, goodbye.
These test flights demonstrated the possibilities offered by EGNOS, the first European satellite navigation service, launched by the European Space Agency, the European Commission and Eurocontrol. EGNOS is made up of a network of around 40 reference stations distributed between more than 20 countries. These stations collect the signals transmitted by GPS satellites and transmit them to computers for processing and improvement, before sending them to geostationary satellites for relay to the ground. At Limoges, the aircraft, which is normally used for calibrating French airport equipment, was specially equipped to conduct EGNOS precision approaches. The aircraft aligns itself with the runway's axis and then starts a descent path to touchdown. The quality of the EGNOS signals is analyzed by comparing the satellite-guided landing phases with traditional means, like the Instrument Landing System, ILS. It's essential to demonstrate that the EGNOS system meets the safety requirements that govern international air traffic, in particular for landings. I think it is a perfect solution, particularly for airfields where there's no precision approach, no ILS, for technical or commercial reasons, or simply because it's out of action or being maintained. We saw it this morning during the flight. The information supplied to the pilot conforms perfectly to what we're used to using. Therefore, that presumably means that there will be no delay or no great delay in getting acclimatized to it. The accuracy and stability of the information are comparable. The minimum that you can expect is about the same. I think that this is really a solution for the future. Civil aviation authorities in Europe and elsewhere are working on this important step forward for air safety by contributing to the European program. One of the great advantages of EGNOS is that it requires no ground infrastructure. Europe still has many airfields unequipped for precision approaches. Thanks to satellite navigation, it's now possible to offer EGNOS information for vertical guidance anywhere. In practice, the positioning service provided by EGNOS is sufficiently precise and reliable for the aircraft to be fully guided through its vertical descent path on approach. Furthermore, the guidance information sent to the pilot is displayed in the same way as conventional means, such as the so-called ILS today. No adaptation problems for the pilots, nor overcosts for their training. Thanks to EGNOS, it will be possible to make available approach help for all airfields, whether equipped with ILS or not. For civil aviation bodies, EGNOS represents several levels of improvement. The GPS can be used for the en route phase up to the non-precision approaches, but if you want to descend the aircraft further, with lower decision heights, 200, 250 feet, then you need the vertical guidance provided by EGNOS, which corrects the errors of the GPS. The advantage of EGNOS is mainly in relation to the first non-precision approaches and to the GNSS, navigation by satellite, that have been published since 2005. The advantage of EGNOS is to provide vertical guidance that actually secures the whole descent path until the aircraft touches the runway. This is a big step for the pilots and also a great comfort for them. This is much more like what they currently have on many airfields in France called the ILS. There are two bars that define the descent path. The pilot has to follow them and align them. With EGNOS, the presentation is exactly the same, which is a comfort for the pilot. The results of the tests at Limoges demonstrate that EGNOS data allow approaches that conform to aeronautic standards. EGNOS is currently in pre-operational service and should be certified for civil aviation in 2008. In the end, this system for GPS enhancement will provide a precision of less than 2 meters, as against 15 to 20 meters for GPS, with an additional guarantee to the signal quality. If there's a problem, an alarm will be sent to the pilot. The only problem is that if the GPS system breaks down, EGNOS will no longer work, which is why we need a European constellation of satellites, Galileo, in orbit to give Europe an autonomous system. Systems equivalent to EGNOS have been set up in the United States, Japan and India. These systems are compatible and interoperable, so an aircraft fitted with a receiver could operate in any area of the globe involved. It would always have satellite navigation support system available without changing equipment. In fact, the long-term idea is to combine all the existing navigation systems to ensure greater support for pilots and the best possible safety for air traffic in Europe and worldwide.